it's 13 degrees. And so it's absolutely essential that you understand that here this, I would say IDF is one of the simplest data models out there. It can be very complex to implement it, but just really try to, or next time when you perform a query on Google, and from the moment on that you look for an important person, a place, or a concept, and you see popping up here on the right-hand side, this interface, do really understand that here you see two examples of the different paradigms. Full text search, which is extremely powerful, but also completely stupid. There are no semantics here. And here on the right-hand side, this is kind of the future of the publishing of structured data. So, before I start to talk a little bit about the history of data models, so this is just a quick overview of some of the work I've done. So, as Gael mentioned, I published a book with my colleague Ruben Verborg, who's very much a die-hard religious believer in the semantic web, and so this book is almost the outcome of kind of a friendly boxing match between him and me, and I think it's original in the sense that it both addresses the dangers but also the possibilities by combining both kind of a humanities and an IT background. And so in June, or in a month or so, I'll publish at the book here a follow-up book in French, which is just a generic introduction to digital humanities, but which includes also an important chapter on linked data. So, normally I prefer to give practical workshops where everyone can, for example, work on an export of their own metadata, and if there's time after the break, and if you have, for example, if you're the responsible or the manager of a large metadata collection and you have some practical questions, please come to me. But so these are really the different elements which I would like to tackle from a conceptual point of view, but I will also give you pointers how tomorrow or with your IT team you could immediately start working on these topics. And so here I use this silly metaphor of apples and coconuts. So apples stand for the results which you can get very easily by using for an organization as ISSN. This is, I think, at the end of the road, what you really want to think about is how to publish your own reference data so that other people can hook up to your authority data, but that involves quite a lot of conceptual, technical, but also economical implications. But so for today, I'll mainly tackle on the apples, or I'll focus on the apples: cleaning, reconciliation, and enrichment. But so before we go there, I would just like to take a little step back and really kind of try to squeeze within 10 or 15 minutes a history, or the shortest possible history of data modeling. And for that, I would like to, I'll just use the flip chart and some practical examples. Is this working? Yeah? Okay, perfect. Brussels tends to be, or Belgium is well known for two things. Unfortunately now, with the whole tragedies which happened, let's try to forget them. But let's say, based on your preference, just imagine here that I have either a tremendous pile of chocolates, or if you're more of a beer fan, that you have here 10 or 15 crates of kind of artisanal Belgian beers. Or here in the context of ISSN, you can also just imagine that you have a pile of 20 or 30 journals. So just imagine that you have here the object of your interest, and you have a pile of those objects, and I ask you, you can either win the boxes of chocolates, the beer, or the journals, if you manage to catalog, to describe as quickly as possible those objects. So let's just imagine, voila, we have here 20 or 30 journals. They're extremely valuable, and you want to get them for your library or your collection. What would be the quickest way to run forward and to give me a set of metadata of those journals? What would you do? Oh, you'll be parler, si vous êtes francophone, voilà, je parle.
Forget to mention, I do speak French, so you can speak to me in French. I can speak in two languages.
What would be kind of the most natural? And imagine you just have a sheet of paper, so you don't have a laptop or any fancy cataloging software. What would be the most or the quickest way of dressing up or to create metadata for those 20 or 30 journals or boxes of chocolate or crates of beer? What would you do? Exactly, and so here we're surrounded by lists. And I would say a list is really the very first conceptual data model, which was, I would say, created when we started developing writing. And I would think, let's say here, if we use the example of journals, probably what would you do is just let's say here, the title, the editor, let's say here, the year was published, etc., etc. So I think probably everyone agrees that making a list is probably the most natural, the most intuitive way of drawing up metadata. So just vertically, you have the different conceptual elements which describe the reality in a concise manner, and then here horizontally you start encoding the different elements in relation to one box of chocolate or one beer or one journal. But so this is fantastic, everyone understands this, but if I would say to you, good news, so who is again here from the Deutsche Nationalbibliothek? If I would mention to you, good news, and or there's another mic here.
Technical problems. Oh, well done. The format is not usable enough for us. We try to have, or we like to have a format that we can transfer into different formats.
Well, I would say from Excel you can transfer to XML or RDF, but why is it not usable?
Because you know, the Excel sheet stops about, I think, about 2 million entrances.
Yeah, exactly.
So we have 30 million, 20 million, and also we want more information than that you have. We want to link, and I think you will forecome to this.
Yeah. But you're absolutely right. So from a technical perspective, doing a search so we call this a flat file. So this is serialized in either TSV or CSV, which you probably all have worked with at some point. But just from a conceptual point of view, let's imagine I have here, so we have, say, let's go back to the box of chocolates. You have 20 or 30 of them, and each time you have 3 or 4 different boxes which were created by the same chocolatier, which has an unpronounceable Flemish name. So let's say here you start to encode the name of the chocolatier, and then three spaces or 3 records further down, you have to re-encode the name of the same chocolatier or of the same editor. But as human beings, we tend to make mistakes, and so also what is conceptually very important in the context of lists is that every time that you're encoding the same reality, you have to encode again the same value. And as we're human beings, voila, we tend to make mistakes. So this model, as interesting and as natural as it is just bound to create and to introduce inconsistencies in how we manage large volumes of data. And so for all of those reasons, voila, I would say starting from the 70s, people from all sorts of different applications domains started thinking about another data model, which would be?
Relational database.
Exactly. So this is, I would say then, I don't know how many of you have done some modeling of entity relationship databases. basis, but as such, you only need to identify three things. I would say here you have an entity. So an entity groups a family of objects which share the same characteristic. And so if we now take the example of beer, let's say here we have a brewer who has probably an address, a name, and he might have, voilà, his chiffre d'affaires, his economical, how do you call it, turnover, voilà. So you associate so these are attributes which define the characteristics of a brewer, and a brewer produces beer. And here a beer can percentage of alcohol and its name, for example. And so what is really difficult philosophically is you actually want to try to cram reality, which is messy and which changes, into a very abstract and a very well-defined format. And so making this decision whether you'll consider something an entity or an attribute, that's the difficult part. But again, you do not want to give this to an IT person. And this is one of the dramas in our application domain, because you just need a pen and paper to do this, and it's absolutely not an IT skill. I would say you're more with a philosophy or a sociology degree to do this. But so I just said that with the first data model, the lists, one of the basic flaws of that model is that you need to represent every time the same reality. Here the beauty is that we can take a step higher on an intellectual ladder, in the sense that once you have encoded the name of a brewer and you need to encode a second or a third case, you just map to the ID of the brewer, which ensures a more consistent encoding of the metadata within your database. And I would say, without any exaggeration, relational databases, voilà, they have been the engine of the information economy, and they are absolutely here to stay. I have some colleagues who yell that RDF will take over the world. Absolutely not. I find that ridiculous. In the century to come, I'm sure that as a model, as a conceptual basis, the relational model will continue to function. But so as beautiful and as powerful as it is, I think everyone probably here in the room also has some horror stories, or that at some point you started to cry, or you wanted to hit your database administrator in the face. When, in what type of context did that happen? Who has never encountered an issue with their database? Any issue, yeah. You have been happily married with your database for, that's then quite a unicum. So again, and especially if you start thinking about the 90s, the end of the 90s, voila, what happens? Yeah. Yeah, but on a kind of if you think about this, kind of the publication of data, what is kind of the biggest revolution ever? Or in the 20th century?
You mean the web?
The web, exactly. So, what do we want to do in the context of the web? Communicate. And so what, I would be very surprised if no one here in the room was entirely happy with their database in the context of the web. I would be very happy for you, but I would be slightly surprised.
Consistency between coding from one database to another.
Exactly. So a database is a fantastic tool as long as you remain upon your island. From the moment on that you try to hook it up to someone else's database, there are two essential problems. First of all, there's an element of technical interoperability. So flat files, so the first model we discussed, the text file, or a flat file is just a text file. You can send anyone a CSV or a TSV file, and you can open it in Notepad. Things are very differently if you run Oracle or even MySQL, an open source database. You can't just copy-paste your database and send it to your colleague in another country and say, here you have my data, you can use them. Because a database is contained in a binary file which includes both the schema and your data. So getting data out of your database and publishing or handing them out to someone else tends to be an absolute nightmare. So for technical reasons, but also just understanding the semantics of someone else's schema, can be extremely complicated. I have followed up several projects in a museum context where evolving from one database to the other, it's not a matter of months, it's a matter of years. So it's, and I think most of you at some point have been in this context. So, first model, lists. Second model, I would say relational databases, as we just discussed in the context of the web. When this model kind of hits a wall, what would be then kind of the third model, or what allowed us as a community to bypass some of these problems? And it was like the fanciest thing to say in a meeting around 2002 to demonstrate that you were really kind of technical savvy.
The so-called network model.
But it's actually, I wouldn't say that a network model is really kind of a data model, but if you really... The whole dynamic web has really allowed us to publish in a very elegant and cheap way data, but at the end of the day, the data model stays exactly the same. MySQL is just a relational database. Someone else has an idea? Almost, you're running a little bit. It's more kind of for programming languages. But if you really think about what format have you started using to send people your data, your metadata, starting from, voila, exactly. So the first data model or the first way of looking at the world was seeing everything like in a gigantic Excel sheet. It's one gigantic list. The second worldview or set of glasses sees everything in by dividing the world in entities which have attributes and which are connected with one another through relations. But now with the third model, actually you start seeing everything as a tree. So at the end of the day, XML is just, you consider or you look at objects as if they are trees. Why? Because everything has a root and has then parent and children items. And I can again encode exactly the same elements which I have been encoding in the list and with the database. So let's say here so I guess that everyone at some point did see some XML. So it's basically markup, but the big difference with HTML is that here you can actually identify or you can define your own tags. But so voilà, XML has been extremely powerful or has been very important for the bibliographic community. Why? Because it allows us to bypass the technical interoperability, because here at the end of the day, voilà, XML files, they're non-binary files, they're just text files. If you would send me 30 million bibliographic records from Deutsche Nationalbibliothek, perhaps I could still open it in Notepad. No? Okay. But let's say if you're below a kind of even a large volume, you can still open and edit XML in any kind of lightweight program. So you're no longer bound to any specific software, and especially for digital preservation purposes, this has really been the big added value of XML. But again, this is an extremely simple example. From the moment on that you have fairly complex, I don't know if anyone here was active in TEI initiatives or TEI projects where you create digital transcriptions of manuscripts. Sometimes TEI even allows you to say, here this specific character was barred and it was corrected, or you can encode up to the most tedious detail an element on the level of a book, a chapter, a paragraph, or even a single character. But so from the moment on that you start working on those projects, also here this XML gets tremendously complex. And again, you need the same thing as we needed with databases, you need a schema. And again, if I want to share my metadata with someone else, fair enough, they can, technically speaking, very easily open up the XML file, but trying to understand it, trying to understand the semantics, again, I'll be obliged to sit down for sometimes a couple of days or a couple of weeks in order to understand the semantics. And so again, we kind of hit a wall, and this is then, voila, where I think you sense me coming. Sorry. Voila, this is then where we end up with, someone already mentioned this a couple of minutes, so the third, or the last, fourth model would be exactly, and here more in particular RDF. And in the sense, we come back to the very first data model, a list. Voilà. And so the whole idea of a graph data model is that you reduce, or your data model is so extremely simple that it makes explicit the semantics itself. So there is no longer a need for an external schema in order to interpret the data. And so this is all based on this notion of having triplets. So just imagine that in this worldview we actually we slice up everything in three parts. So a subject, a predicate, and an object, and think again about what I showed you with Google. Voila. So the subject is Paris, the predicate is, for example, here weather, and then the object or the value is set as such is 13 degrees. So that's really kind of the whole underlying idea of RDF. But what is very important to realize from I would say from a library or from a bibliographic point of view is that the second and the third model we discussed, so the relational database and XML, they're based on what we call a closed world assumption. So only the realities or only the values which respect the schema in a database or in XML, so only the values which respect the schema can be encoded into the database or in the XML information system. Here we're in a radically different setting in the sense that I don't know who invented the phrase, but in the context of the web we always say anyone can say anything about anything. And so here you're confronted with a radical open world assumption in the sense that I can say now here today in Paris at 10 or 10:15, this journal is published under this title, but in China or in Shanghai, or you could just take out your smartphone and encode either exactly the same or an opposing value, or voila. At no point in time I can say this is the amount of information which we have about a certain topic, because voila, it is open-ended. There is no way for which you can say, at this specific point in time, this is the information we have, and the information respects these and these rules. So it's a bit like organizing a party or going out, I would say XML and databases. You go to a very fancy nightclub here in Paris. You pay 50 or 100 euros to get in, and only if you're in a suit and you're white and you have a certain car, you can get in. And that allows you to have a certain consistency in the audience, but it's also a bit boring. So if you, for example, organize more kind of an open-ended house party, or you just say, oh, we'll go to the park, Place des Vosges, just you take some bottles of wine and you put on Facebook the event, voila, you'll probably have a lot more diverse people showing up, and you'll meet people, perhaps interesting, non-interesting people, but voila, it's a different setting. But this also involves a lot of potential issues. I don't know if you heard these stories like 4 or 5 years ago when like a 12-year-old organized a house party in Scotland and they published the event on Facebook, and then 3,000 people came and trashed the house. So that's also a potential issue with this open world assumption. So it's not an accident here that, so you could say we are full circle, we go back with the last model to a list, but the big difference here is for the first, the tabular data, I close here the file. In the context of RDF, you never know when it's closed, so this is kind of open-ended. But it's a bit of a long story, or kind of perhaps I took a little bit more time, but it's absolutely essential for me that everyone understands kind of the... Oh, does this work again? Okay. Voila. So this is really kind of the introductory chapter to the book I published in 2014. And it's absolutely essential that you don't see this from a kind of a linear historical point of view, in the sense that we go from a very stupid basic approach to the most elegant and the most performing, from tabular or flat files to RDF. No, all of these, and I think this is absolutely essential even if you don't care about IT or you don't have an engineering background, that at least when you're discussing, or I think a lot of you manage large IT crews, that you fully understand what are the possibilities but also the limits of every data model. So it's really based on the specific context that you have to make the choice, and please do not make this mistake of just thinking, it's 2016, we should migrate to RDF. Absolutely not. Again, it can be extremely interesting if you want to link to other people's data or publish your own authority data in a very lightweight and a very conceptually interesting approach. But probably at some point you also want to keep consistency over those authority data, and most certainly you will do that from just a classical relational database. And also, and this is a last sneer to IT people, and I apologize to people with an IT degree or profession, but you have to admit that a lot of IT people have this syndrome of the boy with the hammer, and it's, from a human perspective, it's completely understandable. So a lot of IT people, they have developed over the course of 10 or 15 years, for example, querying large sets of XML with XML query, or voila, you set up dynamic databases with PHP MySQL, but at some point, voila, you see a reality and you just kind of smash different realities with the same hammer. And this is really why I insist on kind of understanding the different data models, so that you understand in what context what should be used. And so this is just kind of, let's say, making clear that everyone understands the difference between the different data models. But now, well, I'm an academic, but I'm also a very pragmatic man. Let's try to make things a little bit more concrete. So again, here, this is an illustration of the triples, this data model. And so Sigma, which is no longer existing, is actually a search engine for the semantic web. And the fact that it was abandoned is also quite a good illustration of the failure of the semantic web. But so what you see here is what both a computer and a human being receive as information regarding Picasso. So imagine that you live on Mars, you've never heard about art or Picasso, and voila, great, fantastic, we have RDF in order to make sense of reality. So how would you interpret and understand Picasso? What would Picasso be for you? If you just have a look at I don't know if it's big enough to read. So again, I think about, so we have the subject is Picasso, then you see a certain number of predicates, such as comment, admins, is a, ID, etc., and then a set of values. Just as a computer or as someone from Mars, what would I say about Picasso? He's a puzzle, he's a wallpaper, he is, if I go here to the second page, Picasso is 355 pixels high. So this is just a very kind of simple example of how you have to be extremely careful in the context of the web when you aggregate from heterogeneous sources, values, and metadata regarding a certain concept. It's extremely difficult when you pack those together. I know Europeana is also, or the American Digital Library, are also good examples of what sometimes happens to metadata quality when you put everything together in one big pot. And so for me, linked data has been a gift from heaven to talk about data quality. So data quality from an academic perspective has been a fairly, I would say, important field. But, and again, I try to, now let's say, if you're interested in data quality, there's a lot of rubbish which was published on the topic. So if you only want to buy one book, just buy the Jack Olson book, Data Quality. It's absolute fantastic book. Normally I really like O'Reilly books, and the title Bad Data is probably the best title ever, but the book itself is actually quite bad. And also the three other books, they're extremely academic. They develop theoretical frameworks regarding data quality, but they're not capable of implementing it on the terrain. And also what is interesting is at the MIT, you have a data quality program since 10 or 15 years. But, and based on the work of my PhD supervisor in the past, Isabelle Boydens, she completely criticized this MIT approach. Why? Before I go there, let me just say a word here about this picture. So I was in Congo, in Lubumbashi 2 years ago for an e-learning project. And we had a meeting with the chancellor of the university, and just next to his office was this little cupboard which says, I just took this with a very crappy old iPhone, it says Assurance Qualité, which stands for quality assurance. And the funny thing is, and this is absolutely not a comment on my wonderful Congolese colleagues, but what you see, it's empty. And this is just a very good metaphor to kind of describe a lot of the work here which has been done academically, and especially here this MIT approach. Why? So a lot of engineers, or when database people talk about data quality, what do they say? A database, or the database is of good quality if it corresponds to the reality that it tries to describe. But what is a database? You try to put the empirical world, which always evolves, into, you try to cram it, or you make an abstraction of it and you cram it into a schema. But from the moment on, if I would, let's say, let's say we're going to create a database now, or a schema to describe iPhones. So this is an iPhone 5. If we now sit down together and we create a schema to describe, the weight, it has certain functionalities, it has battery power, but probably by tomorrow Apple will introduce an iPhone 7, and so that will have changes on the schema. So at no point in time, both from a conceptual or a practical point of view, creating this link between the reality and saying, something is of good quality, whether the reality matches the schema. It's just from an operational and theoretical point of view, you can't make that connection. And that's where the work of Isabelle Boydens is extremely powerful. So she actually uses the work by Fernand Braudel, who worked on this notion of the temporalité étagée, or the stratified time. So for those who do not know Fernand Braudel, one of the biggest historians ever, he interpreted the evolution of the area around the Mediterranean Sea by slicing or by analyzing different time levels. You have the long term, which evolves over centuries or even millenaries, where the climate, for example, evolves. Then you have the intermediate time, which is mapped to the economical level, which evolves over decades or centuries. And then you have the short term time level, which is the political level, where if someone gets killed, a king or a politician, it has an immediate impact. And so she uses this hermeneutical framework to develop an analysis of the quality of a social security database in Belgium. So she takes this very kind of a traditional historian or historical perspective and applies it to IT in order to exactly demonstrate that the question, is a database correct? Well, you can't answer that question. It's more relevant or more interesting to ask yourself the question, how do my data and reality evolve through time, and how can I monitor that reality? And so here, it might sound a little bit esoteric, but let's now come back to practice. Actually, how much time do I still have? 15 minutes, okay. So, all of this kind of to mention why it's tremendously important to perform what Thomas Redman in his book Data Quality he calls data profiling. It's actually monitoring the quality of your data. Before you want to publish them out on the web and you want to link them with other metadata, it's absolutely essential that you streamline how you have defined your data. And so traditionally there are different communities which have worked on the topic of data quality. But so in most of the work I've done over the last 4 or 5 years, we've always used OpenRefine, which is initially a Google product, but now it has been put into the open source realm. And I would say in the US, often people talk about it like Excel or spreadsheets on steroids. So I would say it's a kind of a Fisher Price approach to data quality in the sense that it's a very easily understandable interface, but it is very powerful. But and so here you just see a screenshot of what it looks like. Unfortunately, I don't have the time to do a kind of a hands-on approach. If we would have had more time, it would have been interesting. But so what you basically see is a browser window, so the application runs in Chrome or in Internet Explorer, but it is a locally installed software. So it's not that you're sending your data onto a Google server. And from this software, you have access to a large set of scripts and filters which allow you to understand to what extent, or to make an analysis of the distribution of values, and to see to what extent the value... Yeah, okay. Well, I'll wrap up. So if you're interested in these elements, do note there are 2 books. The Facet book is horribly expensive from the Fear Metadata website. So normally I really try to have these presentations in the kind of a workshop setting that I first introduce kind of the theory, and then at a second stage I invite people to come over with their metadata and to work with OpenRefine. Unfortunately, I have to leave after the lunch break, but so if some of you have interesting metadata and you're interested in an academic collaboration, please come and see me, and I would be more than happy to set up collaboration. So I'm always interested, or the dirtier or the more complex your data are, the better for me, because then I can write papers about it. Voilà, so feel free to get in touch. I'm based in Brussels, but I travel a lot, so I would be very happy to meet up with some of you if you're interested in some of these aspects. Thank you.